Hey there, advanced math kids. This is 9.5, sine and cosine curves. I'm going to try to keep this going pretty smoothly. So I just got off with you. It was good to see you again for the first time. I'm kind of ready to go home, but I told myself I'd get this done. So I'm going to get this one done and try not to go too fast in it through you. Won't be a whole lot of sketching today with the graphs. It'll be mostly understanding, interpreting different parts of a sine graph. The amplitude and period are two important things of a graph. Amplitude is how tall your graph is, and period is how long it takes you to complete one cycle. So we'll talk about that more a little bit later on. So your basic sine graph is right here. So remember, sine and cosine are what we call periodic functions, which means they repeat themselves. They get the same y values over and over again. Okay, so the graph goes up, and then goes back down, and it goes back up, and then it just repeats itself over and over again. This comes from the unit circle and how things repeat themselves. So you start at 0, and if you're looking at your y values, you are increasing to 1, and then you start coming back down to 0. You're going negative to -1, and then you're coming back up to 0. So remember, look at the y values on the graph. They're increasing to 1, coming back down to 0, decreasing, dropping to -1, coming back up to 0. And then when you get past 2 pi to bigger things, 13 pi over 6, 9 pi over 4, 7 pi over 3, those bigger, 3 pi over 2, not 3 pi, 5 pi over 2, then you just start repeating these y values again. So as your angle increases and you get revolutions and revolutions and revolutions, your y values go up, and then they start coming back down. So that's the periodic function of this. Two important things is sine will always start at 0, 0. Cosine will start at 0, 1. Okay, that'll be good to recognize what you're doing with this. So sine graphs will have the point 0, 0 on them unless there's some sort of transformation, which we'll talk about that. Okay, cosine we'll get here in a little bit. And so here's your cosine graph. So cosine of theta, that is going to include the point 0, 1. So cosine, I always say, starts high, and the sine starts at the origin. The range for these are from -1 to 1, if you can see that, -1 to 1. Okay, just like on the unit circle, it goes from -1 to 1. The period is 2 pi. So if you go one full revolution around, that's 2 pi. So that's what the period is. The time for one period of function is called one cycle of the sine graph. So the black portion of the graph represents one period of the function, and it's called one cycle of the sine curve. So period, amount of time needed for one cycle. Amount of time needed for one cycle. So cosine, again, the period is 2 pi. You need 2 pi units of time for one cycle. It starts high, drops all the way down, then goes back up. So if you're doing the cosine of 0, now you're looking at the y values, or the x values. Remember, cosine is x. So cosine is 1, and then it starts dropping to 0. It goes to -1, and it comes back up to 0, then it comes back up to +1. The cosine starts high, sine starts low. The domain is a set of all real numbers, so -infinity to infinity, and this is your range, -1 to 1 inclusive. Each function has a period of 2 pi. When graphing, be in the radian mode. Okay, if you're using your graphing calculator, if you are in degrees and you graph the sine of x, you're going to get not much action. You saw a little bit there, maybe a little bit at the end. Okay, we can adjust our window to see it, but remember, a full revolution for cosine in degrees is 360 degrees. So if you stretch this x-axis to go from -360 to +360, now you're going to start seeing the graphs show up. So almost all the time, the graphs are not graphed in degrees, they're graphed in radians. So radians, I'll go back to my standard window. So this is negative 10 to 10, and there you can see the sine graph. Okay, and you can restrict your y-axis to get down to what you want as well. So if you're graphing are graphing in degree mode, then the period is 360. Your graphs get really wide. You have to really expand your x-axis. I think these are the same graphs. Okay, the sine graph starting at 0, 0, cosine graph starting at 0, 1. Note that the sine curve is symmetric with respect to the origin, whereas the cosine curve is symmetric with respect to the y-axis. Okay, so the sine function is odd. Remember, an odd function is if you plug in a negative x value, or the opposite of an x value, you get the opposite of the y value. And the cosine is an even function. So odd functions were something like an x cubed, y equals x cubed. Okay, they were symmetric to the origin. Even functions, y equals x squared, they are symmetric to the y-axis. Okay, so x cubed and x squared, even and odd functions, these follow the same properties. Okay, I'm just going to make sure all the vocab questions, I'm covering all those. Talk about that yet. Okay. To sketch the graphs, these key points, you won't have to sketch anything. The key points, though, that you always look for are what they call intercepts and your maximums and minimums. So if you can find out one full period, if you're on a sine graph, you know, okay, I'm starting at 0. After one period, I have to be back at my starting point 0. Halfway of that is going to be a 0. In the first quarter, you're going to have a maximum. Second quarter, you're going to have a minimum. Sorry. I grabbed some almonds and peanuts for a snack. I am feeling healthy. I am good. I just got some nuts stuck in my throat. Cosine starts high, drops to the bottom halfway, then comes back up to the top. Okay, we're not going to worry about sketching stuff right now. Okay, amplitude and period. In the remainder of the section, you'll study what we have, the A, B, C's, and D's in equations of the forms here. So here's a link. If you can pull this up and open it up, you can play with some of this. I'll do that now. Okay, so these are our sliders. This is the sine graph. You notice my scale graph settings, I went from negative 6 pi to 6 pi, put them in terms of radian, counting by pi over 4, y-axis negative 4 to 4. Okay, so the first thing we need to look at is what they call the amplitude. And the amplitude is the height of the graph. Okay. So down here, let's get the result of the graph, A sine x, ranges between opposite of A and A. So the number that's in front of the sine or cosine, this number right here, that tells you the height of the graph. From a midline. And it represents half the distance between the maximum and the minimum. So on our most basic functions, okay, A is 1. So when I go back to these graphs here, this is just y equals 1 times the sine of x. 1 times the sine of x. So that means from our middle line that goes to the middle of this, I'm going to go 1 unit up and 1 unit down. So on the graph here, if we adjust our A value, it's going to affect the height of the object. So right now we're going from negative 1 to 1. If I play it, it expands and it contracts. So when it goes negative, that's a reflection in the x-axis and it turns around. So the larger the A value, the higher it is. So if you ever listen to AM radio stands for Amplitude Modification Radio. So the different radio stations are being broadcast using different amplitudes. So one radio station might have an amplitude of this, another one might have an amplitude of this, and so you have to tune your radio to the right one to hear what you need to there. So AM radio, amplitude modification. Okay. FM stands for frequency modification, changing the frequency which is associated with the period. Okay, there we go. Okay, so the amplitude is just the absolute value of A. So, state the amplitude and range for the following functions. So here is the 1/2. Your amplitude would equal 1/2. So that means from your midline, you're going to go up 1/2 and bottom 1/2. So your range would be from -1/2 to +1/2. Okay. Here, your amplitude is 3. So your range would go from -3 to +3. The height of the object there is 3. Okay. Okay. The graph of y equals -f of x is a reflection in the x-axis. So that's just saying if you have a negative a value, it reflects it over the x-axis. Making progress. Period. The period, the amount of time it takes to complete one cycle. Okay, this is our formula for period, 2 pi over b. The period of y equals a sine. Now it's an inside function. Okay, remember outside functions cause vertical adjustments, so that a is doing a vertical stretch and a vertical shrink. Inside multiplications cause horizontal stretches and shrinks. Okay, so that b is going to stretch your sine out, make your periods longer, or condense it, tighten it up. Okay. Okay, yep. So note that if b is between 0 and 1, it's going to be greater than 2 pi. Because if you have a number that's less than 1, this is going to get bigger. Rules, number sense. If b is greater than 1, it's going to be a horizontal shrink. That's going to get smaller than 2 pi for your period. Okay. So state the amplitude and period for the following functions. You have a lot of questions just like this. So here, this is your A. So amplitude equals 2. This is your B. So your period equals 2 pi over 5. Okay, and we'll just leave it like that. If you can reduce it, reduce it. Okay, I want to look at a lot of these that have fractions in here. Those are kind of the trickier ones. Amplitude, that's easy. Amplitude is 3/4. So it's 3/4 from the midline. Your period. Okay, here your B is not 2. Your B is 1/2. The number being multiplied by x is 1/2. So here your B is 1/2. So your period is 2 pi divided by 1/2. So that would be 2 pi times 2 times the reciprocal. So your period is 4 pi. So that B value is less than 1, between 0 and 1. So it stretches your period out. That's a longer one. Period is associated with frequency. The reciprocals, we'll cover that later. But that's where you get FM frequency modifications, changing how many oscillations you have in a certain amount of time. Amplitude here, 1/2, right there. Your B value in this case is pi over 3. So your period is 2 pi over 3. That is 2 pi times 3 over pi, so 2 pi over 1 times 3 over pi, pi's cancel off, you get 6 for your period. You don't have to have the pi in there. So your period here is just 6 units. Amplitude is 1/4. Make sure you're writing this stuff down as you go through it, either on your own notes or these printed off. Do not just watch me and say, yep, got it, especially this period. The more you write down, the better you will figure things out. So 2 pi, here your B is 2 pi, so 2 pi over 2 pi equals 1. It's a period of 1 there. Okay, translation, sine and cosine translation. The C is starting with a horizontal translation. And this gets really confusing. Let's just go on to That does not say it. Did I copy the wrong thing over? Okay, oh, right there. The number C over B is the phase shift. So that is called a phase shift. That is a horizontal translation. That's a phase shift. So notice the formula has a minus C in there. Okay? So when you plug the C in, when you plug the C in, it is the opposite of whatever you see up here. Remember, things that happen on the inside are kind of backwards. And my finger is bleeding. That looks good. Sorry. I'll keep that off. Cut it yesterday. Okay, so C over B is the phase shift. So what that looks like, analyze, that means state the characteristics of the graph of this. So the characteristics are your amplitude, period, and shifts that you're having. So here, your amplitude is 1/2. Okay, your period is 2 pi over B. In this case, there's a 1 there, so B equals 1, so 2 pi over 1, so your period is 2 pi. And you have a phase shift that is C over B. So in this case, C is pi over 3. It's not negative pi over 3, it's positive pi over 3. So this would be pi over 3 over 1, which is just pi over 3, which means your entire sine graph has been shifted pi over 3 units to the right. Okay, let me give you a demonstration of that. Here's your B. So this is adjusting your period, condensing it. That's a higher period, longer period. Negatives cause a reflection in the y-axis. You should have a link to this in the notes. Okay. 1. And your C, see how it moves it. Phase shift to the right, phase shift to the left. So you can probably guess what the C is going to... Ooh, pretty close to 0. So the D is going to be your vertical translations. Up and down. So now we're going to have fun. Alright. Alright, okay, this is wasting video time. But you can play around with that. So here, see the negative? That just means it's been reflected over the x-axis. Your amplitude is still 3. It's a positive 3. It's the absolute value of that. Okay, here's your B value, and there's your C. C is going to be negative 4 pi, because it's a plus sign. C is negative 4 pi. So your period is 2 pi over 2 pi, which is 1. And your phase shift is negative 4 pi over 2 pi, which is 2. Negative 2. Which means the whole graph has been shifted 2 units to the left. Okay? Let's do it again. So vertical translation, that's the D. That's on the outside, plus or minus. So analyze these characteristics. So you see that 1, that means it's just been shifted 1 unit up. So we have our amplitude is 1 because of negative 1 right there. Period, there's a 1 there, so that's 2 pi over 1. Phase shift would be negative pi over 1, so that's negative pi. And we have a vertical translation up 1. So it's up 1, that negative is a reflection. Okay, this one, amplitude is 4. Period, there's a 1 there, so it's 2 pi over 1. phase shift would be -5 over 1, so -5. And you have a vertical translation up 2. So that changes your midline. So if you graph these, you have to move, imagine your x-axis is 2 units up, and then you graph it going off that line. Okay. Use a graphing utility to graph that. Okay, so when you're solving these, you have a question like this. It says use a graphing utility to graph y1 and y2 in the interval -2 pi to 2 pi. Use the graphs to find the real numbers x such that they are equal. So what you're finding here is I want to find out when does sine of x equal -1/2. But I have to restrict my answers to -2 pi to 2 pi. Remember, this is cyclical, it's periodic, so there's an infinite number of answers. So they have to limit, say, okay, I just want the answers in this range here. So that link there, which you can find on the notes, would open up a graph like this. So I have y equals sine of x, and y equals -1/2 x. On my window, I changed it. I went from -10 to 10. I want to go from -2 pi, just type pi, and you can get that, to 2 pi. I'm stepping by pi over 4. So I only want the answers that are in this window here. So I see it happens there, and look at that, it even gives me it in radians. Exactly, that's nice. Here, here, and here. So I actually have 4 answers in that range. So you use the graph, you get it graphed, and those would be your answers. So they'll just give you one box for that, and you enter your answers in terms of pi as a comma-separated list. So just type all 4 of these answers, put a comma in between them. Mathematical modeling. We're not going to get to that now. So that is it. So your assignment starts off with some of the vocab stuff, 1 period of a sine function. You don't need to see all those right now. And then it says find the period and amplitude. You have a lot of those, period and amplitude, period and amplitude. Find A and D. So A is the amplitude and D is the phase shift. So you have to find the D. Remember, go off the midline. So like this looks like this is the middle right here. It goes from -6 to -2. So your amplitude has to be half of that, and then your D is going to be the fact that you shifted it down 4 units in this case. Okay. Find A, B, C, and C for the function. Notice it's a sine function. So sine always starts at 0, 0, so I don't think there's been a phase shift in this one. So C in this case would be 0. You want the amplitude and the period. Notice the period is 4 pi. Okay? So you need to find the B value. So what happens with that is if you know the period, so if you know the period, in this case, let's say it's 4 pi, you have to set equal to 2 pi over B, and then solve for B. Okay. So I know my period's 4 pi. I have to say, okay, I want 4 pi has to equal 2 pi over B. So anything on the bottom, multiply it across. So 4 pi times B equals 2 pi. Divide by that 4 pi, and B equals, pi's cancel off, 1/2. So that's the B value. You do not put the period into the function. You have to find the value of B by setting it equal to that. Okay. Now in this one, it's a sine graph, but notice it has starting up high like a cosine should. So that's actually been shifted. So here, notice first of all your period is 4. So 4 equals 2 pi over B. You have to solve for B. Your A looks to be the distance from the midline, which is the x-axis to the top. And now the C value looks like you moved it over 1 unit. So C over B has to equal 1. Now once you find the value of B, listen carefully, find the value of B, then you can plug that into the equation, C over B equals 1, and find the value of C. Okay, there's a graphing utility question, and then just putting it all together here in last 2 questions. Okay, So write down what other questions you have, what you're struggling with, and we can cover that next time we meet. So good luck, and I'll see you soon.